This lecture is on arcs, arc measures, arc lengths. So let's get into some vocabulary first. Here we have a circle which is centered at point X, and this is called a central angle, AXD or DXA, and it's a central angle because it has as its vertex the center of the circle. And it intercepts this arc dA. An arc is a piece of a circle. Now we have minor arcs, which are less than 180 degrees, and we can denote these by two letters or three. Two letters say arc AC or arc EA. We have major arcs, which are bigger than 180, and for major arcs you need to have three letters, such as arc CBA. If you just said arc CA, that would assume the minor arc. Arc CBA means start at C, go through B, all the way around to A. So that's this arc in black is arc CBA. You could also call it, say, arc ADC. That's the same arc. That's a major arc. And a semicircle is exactly half a circle, so that is 180 degrees, and that would be, say, BA or, well, AB. And so minor is less than 180, and you can use two letters or three. Major's greater than 180, you need three letters, and a semicircle is 180, it's half a circle. Now it turns out that the measure of a central angle is equal to the intercepted arc. And so you have the measure of angle AXD, and that's equal to the arc measure. Now, we're not talking about the length of the arc yet. We'll talk about that later. It's the measure of the arc. So, again, the central angle's measure is equal to the measure of the arc. So let's do some examples. Okay, here we have this circle, 45-degree angle, 90-degree central angle, 90-degree central angle. If we want to find arc BC, let's see, BC is intercepted by this angle here, which is 45 degrees. Therefore, arc BC is 45. Arc CA. CA is this arc, and so that would be this angle here, which is 45 plus 90, 135. Arc ADC. So that's a major arc all the way around here. So ADC, we've got, well, there's a couple ways to do this. We could say this arc here is going to be, let's see, if this is 90 and we have 90, we can subtract these from 360 to get 180, subtract 45 and you get 135 for this angle. So arc ADC is going to be 135 plus 90, which is 225 degrees. Another way to look at it is to say arc ADC is the whole circle, which is 360, except for these two. So you can subtract 90, subtract 45, still get 225. Now CDB, that's how we'll do CDB. CDB is the entire circle except for this arc here, so that's 360 minus 45 is 315. Arc CD, well, we see that's 90. And arc BAD, BAD is going to be 90, 135, so that's 225. So here we see it's 225. Now a little application of this idea is with pie charts. So here's a sample pie chart we'll construct. We need some data first, so this is taken from a class where we look at eye color. And so out of 27 people, there were 7 people with green eyes, 3 hazel, 6 blue-eyed people, 11 brown eyes. And so we have to get percentages, and so we do 7 divided by 27, 3 divided by 27, 6 divided by 27, 11 divided by 27. We get these percentages. And they want to convert the percentages into degrees to make a pie chart. And so since there's 360 degrees in a circle, you do each percentage times 360. So 0.26 times 360, 0.11 times 360, and so on, and you get this number of degrees. And so now, if we had a protractor, of course, we could make it more accurate, but just doing it a little roughly, first I'm going to do 94, and I know that if I want to do 94, if I go straight across from here, that's 90. So I'm just going to go slightly down a little bit. So instead of going straight across, I go down a little bit to make it a little bigger, and that's going to be green eyes. And then let's see, we could try, let's try the blue eyes next, because that's a little bit less than 90. So rather than going straight across to the left, I'm going to come up a little bit to there, and so we'll say that that's the 79, and so that was blue eyes. And then we need, let's see, we need 147. So 147, that's, well, it's getting closer to 180, but it's certainly not half a circle. It's less than half a circle, so that's going to be the brown. Half a circle would be if I drew this thing straight across. I don't want to do that. I want to leave open about 40 degrees for the last one, so maybe I'll do this. That'll be my brown, which means my hazel's in there at about 39. So this is brown and this was blue. Okay, now we want to get towards arc length. So to do that, we have this formula first for circumference of a circle. So there's a difference between arc measure and arc length. Measure doesn't matter how big or small the circle is. An arc will not change its measure, but the length will get bigger as the radius gets bigger, as we see, because the circle just is larger. So circumference is 2 times pi times radius, or pi times diameter. Now, as far as leading up to arc measure, or arc length, rather than talking about the entire circle, let's say we only care about 180 degrees out of the total 360. And so that reduces to 1/2. So now we're only concerned about really half of the entire circle. Or maybe instead of 180 out of 360, as we see here, what if we had 90 out of 360? So what if we just wanted to take a look at this portion of the circle? Well, that reduces to 1/4. So this is only 1/4 of the entire circle. What if instead we had 60 over 360? So we just want to look at this part right here, 60 over 360. That reduces to 1/6. Or maybe we want to look at something different, like 150 over 360. So that's this arc here. 150 over 360 reduces to 5 over 12. In every one of these cases, though, we're only looking at a fraction of the entire circle. The entire circle is the circumference, but we only want a fraction of it, which is determined by this angle. Whether this angle was 180, or whether it was 90, or 60, or 150, we only want a portion of it. So here's our formula then for arc length. Our formula for arc length is right in here. It's this central angle, theta, divided by 360, because that's the portion of the circle you want, times the entire circumference, 2 pi r. So here's the whole thing, and this is times the part of it that you are interested in. So let's take a look at some examples now. Okay, here's our formulas again. All right, if you want to find the circumference, it's 2 times pi times radius. So that's going to be 2 times pi times 16, which is 32 pi. Over here, this would be 8, so 2 times pi times 8 is 16 pi. All right, here we have identifying some arcs. So if we're trying to find major arcs are more than 180, so you could say something like EBF. So that's an example of a major arc. EBF, because we start at E, go through B all the way back to F. A minor arc, well, you could say DB, that's clearly less than 180. Semicircle, well, AE is a diameter, so we can just say, we'll just say ADE to indicate that we mean this side rather than this side over here. Adjacent arcs are arcs next to each other, so that would be something like FE and EBA. Those two are adjacent. And an acute central angle, you could say angle BCD. Okay, quick pie chart. These are percentages. We want to get degrees. Again, to convert percentages to degrees, you simply multiply by 360 because there's 360 degrees in an entire circle. So for potatoes, we would do 0.088 times 360 degrees, and that's the angle in here. Okay, now we're doing arc measure again, and we'll get on the last thing, arc length. If this is 90 here, we know this is also going to be 90. If this is 130 and these have to add to 180, this will be 50. So now AE is 90, ED 50, DBA is 130 plus 90, so that's 220. AED is 90 and 50, which is 140. Note we could have just said arc AD, same thing in this case. Arc ABD, which is definitely a major arc, so you need all three letters, is 90 and 130, so that's 220. And then BD is the 130. Okay, now some arc length problems. Arc length, again, was the angle over 360 times 2 pi r. So the angle for arc AB is 90 degrees over 360 times 2 times pi, and the radius is 12. So this becomes 1/4 times 24 pi. It's 2 times 12 is 24, and this reduces to 1/4, so I get 6 pi inches. So note that the arc has a measure of 90 degrees, but it has a length of 6 pi inches. Two different things. This arc FH, this is 90 over here, it has a measure of 135, 90 plus 45. Its measure is 135, but its length is going to be 135 over 360 times 2 times pi times 3. So 135 over 360 is 3/8 times 6 pi, and we can cancel these guys, and we get 9 pi over 4 meters.